Ideal gas law states that the volume of a given amount of gas is directly proportional to the number of moles of gas, directly proportional to the temperature, and inversely proportional to the pressure. The given formula is PV is equal to nRT. P means pressure, V means volume, N means number of moles, R is universal gas constant, T is temperature.
For example, 5.6 grams of solid carbon dioxide is put in an empty sealed 4 liters container at a temperature of 300 Kelvin. When all the solid carbon dioxide becomes gas, what will be the pressure in the container? First, only the mass of solid carbon dioxide is given, so we must convert it into moles by dividing 5.6 grams of solid carbon dioxide to its molar mass of 44.009 grams per mole, resulting to 0.13 moles of solid carbon dioxide. Using the formula for ideal gas law, PV is equal to nRT, we can derive the formula for pressure. This results in an equation of P is equal to nRT over V. Carefully substitute the given variables. Solving correctly, we will come with an answer of P is equal to 0.7831 atm or atmosphere. And this is the ideal gas law.
Boyle's law. Boyle's law is an ideal gas law which states that the volume of an ideal gas is inversely proportional to its absolute pressure at a constant temperature. The law applies only to ideal gas which allow only pressure and volume to change. In other words, the product of pressure and volume is constant for a fixed mass of ideal gas at where P denotes pressure of the gas, V denotes volume of the gas, K is constant and holds units of force, times, and distance.
For example, neon sample occupies 4 liters at a pressure of 5 times 10 raised to 4 Pascal and 273.15 Kelvin of temperature. Calculate the volume of the sample at standard temperature and pressure. The given initial conditions are the pressure of 5 times 10 raised to 4 Pascal and the volume of 4 liters. The final condition given is the standard pressure, which is 101,325 Pascal. To get the final volume, we need to multiply the initial pressure and the volume.
Charles' law is a special case of the ideal gas law. It states that the volume of a fixed mass of a gas is directly proportional to the temperature. This law applies to ideal gases held at a constant pressure, where only the volume and temperature are allowed to change, while the mass of the gas doesn't change. Charles' law is expressed as V sub 1 over T sub 1 is equal to V sub 2 over T sub 2, where V sub 1 is the initial volume, T sub 1 is the initial absolute temperature, V sub 2 is the final volume, and T sub 2 is the final absolute temperature. It is extremely important to remember that temperatures are absolute temperatures measured in Kelvin, not degrees Celsius or degrees Fahrenheit.
For example, a gas occupies 221 cubic centimeters at the temperature of 0 degrees Celsius and pressure of 760 millimeters of mercury. What will its volume be at 100 degrees Celsius? Since the pressure is constant and the mass of gas doesn't change, you know you can apply Charles' law. The temperatures are given in Celsius, so they must first be converted into absolute temperature Kelvin to apply the formula. On the problem, the initial volume is 221 cubic centimeters. The initial temperature is 0 degrees Celsius or 273.15 Kelvin, and the final temperature is 100 degrees Celsius or 373.15 Kelvin. Now, the values can be plugged into the formula to solve for the final volume, which is equal to the product of initial volume and final temperature divided by the initial temperature. Then the answer, rounded off to the nearest hundreds, is 301.91 cubic centimeters. And that's all for the Charles' law.
Mutuc's law. Mutuc's law is an ideal gas law which states that at a constant volume, the pressure of an ideal gas is directly proportional to its absolute temperature in Kelvin. The law can be expressed as follows. P1 over T1 is equal to P2 over T2, where P1 is initial pressure and P2 is the final pressure. Both the pressures are in the units of atm, or atmospheric pressure. T1 refers to the initial temperature and T2 refers to the final temperature. The temperatures are measured in the units of Kelvin.
In example, at temperature of 250 Kelvin, a gas in a cylinder has a pressure of 1.5 atmosphere. If the initial pressure of the gas was 1 atmosphere, what was its initial temperature? Now, we have the variables of initial pressure equal to 1 atmosphere, final pressure equal to 1.5 atmosphere, and a final temperature of 250 Kelvin. Applying Gay-Lussac's law, we get the formula of T sub 1 is equal to P sub 1 multiplied by T sub 2 over P sub 2. After substituting and solving, you'll get an answer of initial temperature equal to 166.67 Kelvin. And that's all for the Gay-Lussac's law.
Avogadro's law. Avogadro's law states that equal volumes of gases at the same temperature and pressure contain equal numbers of molecules. This is directly proportional that if you added helium gas in a balloon, the volume will increase, and if you decrease its volume, the amount of helium will decrease as well, while remaining the temperature and pressure as constants. So, how do we compute for it? First, Avogadro's law follows this formula. V sub 1 over N sub 1 is equal to V sub 2 over N sub 2, where V sub 1 is the initial volume, N sub 1 is the initial amount of gas, V sub 2 is the final volume, and the N sub 2 is the final amount of gas. So, for example, we have 5.3 liter container that contains 2.5 moles of helium gas. What is the volume now if you added 3.6 moles of helium gas in the container? Our V sub 1 is 5.3 liters. The N sub 1 is 2.5 moles of helium gas. Then our N2 will be 6.1 moles of helium gas since we added that 3.6 moles in the N sub 1. So, the V sub 2, which is the final volume, is the missing value that is needed to find. So, going back to the formula, let's cancel out the N sub 2 by dividing it to itself and multiply it with the V sub 1. Our formula now will look like this. Next, substitute the given values to the formula. Then cancel out the unit moles of helium to remain the unit liters. After that, multiply the 5.3 liters to the 6.1 and divide it to 2.5 to get the final answer. So from 5.3 liters, the final volume now will be 12.93 liters. That's all for Avogadro's law.
Combined gas law. The combined gas law combines the three gas laws: Boyle's law, Charles' law, and Gay-Lussac's law. It states that the ratio of the product of pressure and volume and the absolute temperature of a gas is equal to a constant. Unlike the named gas laws, the combined gas law doesn't have an official discoverer. It is simply a combination of the other gas laws that works when everything except temperature, pressure, and volume are held constant. There are a couple of common equations for writing the combined gas law. The classic law relates to Boyle's law and Charles' law to state the equation PV over T is equal to K, where P is equal to pressure, V is equal to volume, T is equal to absolute temperature, which is Kelvin, and K is equal to constant. Another common formula for the combined gas law relates before and after conditions of a gas, which results to this equation.
Example: find the volume of a gas at STP when 2 liters is collected at 745 millimeters of mercury and 25 degrees Celsius. The given variables were the initial pressure of 745 millimeters of mercury, the initial volume of 2 liters, initial temperature of 298.15 Kelvin, the final pressure of 760 millimeters of mercury, the final temperature of 273.15 Kelvin, and the unknown variable is the final volume. By manipulating the combined gas law formula, cross-multiply to clear the fractions. Divide P sub 2 T sub 1 to isolate V sub 2. Plug in the numbers and solve for V sub 2.